Hello. Good morning, Nilanjan sir.
Good morning, ma'am.
Good morning, sir. Sir, we will start within 5-10 minutes. The participants are joining. Hello.
No problem, ma'am. No problem.
Yes, yes. Okay.
Good morning, Nilanjan sir.
Good morning, ma'am.
Let's wait for 4 more minutes, and then we shall start at 10 a.m.
Fine, fine. No problem.
Okay. Thank you, sir.
Kulkarni madam. Hello.
Ma'am. Hello.
You
Yeah.
can start.
Yeah. Okay.
Say name. We can
Yeah.
start.
A very good morning to all. I am Mrs. Vaishali Kulkarni. On behalf of JSPM's Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication, welcome our today's speaker, Dr. Nilanjan Dey, sir. And also, I take it as a great privilege to introduce our today's speaker, Dr. Nilanjan Dey, sir. Sir is an associate professor in the Department of Computer Science and Engineering, JIS University, Kolkata. He is a visiting fellow of University of Reading, UK. Previously, he had held an honorary position of visiting scientist at Global Biomedical Technologies in USA. He was awarded his PhD from Jadavpur University in 2015. He has authored, edited more than 70 books with Elsewhere, Vele, CRC per Press, and Springer, and also published more than 300 papers. He is the editor in chief of the International Journal of Ambient Computing and Intelligence, associated editor of IEEE Access, and International Journal of Information Technology Springer. He is the series co-editor of Springer Tracks in Nature Inspired Computing Springer, series of co-editor of Advances in Ubiquitous Sensing Application for Healthcare Elsewhere, series editor of Computational Intelligence in Engineering Problem Solving and Intelligent Signal Processing and Data Analysis CRC. His main interest includes medical imaging, machine learning, computer aided diagnosis, data mining, etc. He is an Indian ambassador of International Federation for Information Processing. He is a young ICT group and senior member of IEEE. Sir has been listed in the world's top 2% scientists in 2020. So on behalf of the department, we welcome you, sir. So I request now, sir, to take over the session. Over to you, sir.
Thank you, ma'am. Thank you very much. A very good morning to all of you. Let me share my screen. My screen is visible?
Yes, sir.
Oh, fine. So next 1.5 hours, we will discuss about biometrics. So biometrics, the present and what was the past also, and how can it be used for forensic sciences. So once we talk about user authentication, we talk about three things. There can be three different types. One is called knowledge-based authentication. One is called position-based authentication. One is called biometric-based authentication. So knowledge-based basically deals with numbers. So traditional password like PIN or your normal password, this all comes under the knowledge-based one. Position-based like tokens, like smart card, like QR code, all this comes under position-based. And once we talk about biometric-based, there are physiological or behavioral biometrics. So physiological biometrics, we all know under this finger scanner, iris scanner, retina scan, or hand scan, or facial scan, these all comes under that. And behavioral like signature, like gaits, like hand stroke or key dynamics, or eye movement or mouse movement, this all comes under behavioral authentication, based authentication. So this is one basic taxonomy of user authentication. Now, once we talk about physiological modality, that basically deals with the shape and the size of the body. So as I already said, it might be fingerprint or hand geometry recognition system, I mean DNA recognition system, retinal recognition system, etc., etc. Once we talk about behavioral modality means which actually related to the change to the human behavior over time. So as the time passes, the human behavior also changes, but some certain behavior is very much notable, which actually helps to identify a person. Like a gait study, like apart from gait study, might be the rhythm, the way you are typing the keyboard or the signature, etc. Now there is a combined form also, which is basically a hybrid of this physical and the physiological and the behavioral modality. Like for example, voice recognition, where the health and the size or might be the shape of the vocal cord or the nasal cavity or the mouth cavity or the shape of the lip, the way your lip is moving. Apart from these, physical modality, we can also consider the age or the illness or say emotional patterns, these all. So it's a combination of both behavioral and physical modality. Now we will talk about one by one. Very first, once we talk about fingerprint recognition system, which is very primitive one. Based on the unique fingerprint, what we actually try to find out the ridges, the grooves, and the direction of the lines. So it can be categorized into three different patterns. One is called loop formation, one is called hole formation, and one is called arc formation. So if you study the arc, there can be different types of arcs also, like tan arc. And if you go through the formation of the loop, there can be right loop, there can be left loop, there can be double loop. So there are different variations, but by which we can actually distinguish finger print, that is called the minute features. So once we talk about minute features, there are two different types of minute features, classes of minute feature. One is called bifurcation, one is called spots. The spots are basically ridge ending. So what is that? Let's have a look into this. This is called star delta tri radii. What is that? Basically, it's a meeting point of three different fields. It might sometimes form a star. It might sometimes form a delta. In cases of arc, there is no formation of such kind of star or delta, but in hole or loop cases, you can observe there are some star formation or delta formation, which actually helps to identify a particular pattern of a finger. Now, bifurcation or the spot, which I actually we are talking about, there can be two types. One is the ridge bifurcation, where there is a bifurcated the ridges from the ridges, or the ridge can be ending. So there is a sudden stop. So here, for example, this one is bifurcation. There is a sudden stop, which is called a ridge ending. So from there, this bifurcation or ridge ending, we convert this whole thing into an image matrix, which is basically a local pattern of that particular finger. Now, these minute patterns can be different types. Once we talk about ridge, it can be an island, it can be an ending, it can be a simple dot, it can be enclosed form, or it can be a single bifurcation. So there are different subcategories of ridges also, which are more minute features, are trainable features for this hand finger recognition system. So there can be termination, there can be bifurcation, there can be leg formation, there can be points, there can be crossover, etc., etc. So these are all different features, or rather minute patterns, which actually helps to identify a person finger. Now, once we talk about minute feature matching, the first matching which comes into our mind is the feature point matching. Suppose there are 100 strong points, feature points. We are trying to map with the other one. So there are one-to-one feature mapping. So if there is one particular point, feature point is not matching, then the matching score will automatically degrade. But the thing is, the way we are putting the finger is not always in the same way we are putting very next time. So sometimes it needs registration. We have to register the image. After that, we need to compare so that the accuracy level, the similarity score will increase. The major challenge of this minute feature-based system, where the image quality is a major issue. Because if the quality of the image is very low, the number of feature extracted is also very less, and one-to-one mapping is not possible. So what we need to do, we have to enhance the quality of the image. We have to extract the features. Then we have to go for further registration process. Once you register, then might be one-to-one mapping is possible. And once you put this into a 2D matrix, 2D say might be graph formation, that will give a similarity score. So how much similar your finger with the other finger is. So for that, the first system is the minute feature-based system. And this particular system is only one major limitation is it's only deals with the local features, local positions, of the ridges and the better to say the bifurcations at the edge point, end points, and the major issue is the quality of the image. Now coming to the second category, which is called correlation based approach. So in this approach, we not deals with the local features, rather deals with the global features, where the quality is not a major issue, where we compare the template and the query image, that we try to find out the correlation, and that gives a matching score by which we try to find out the correlation based findings, means is it matches or not matches. So quality is not a major issue, or sometimes we look into the global features also. So this is second way of matching technique. And the third technique, which is very widely used, which is called pattern based. And in this pattern based, we try to map the pattern of the arc, hole, and the loops. We have a stored template and we have a candidate fingerprint. From there, we try to find out the binary patterns and we try to map those binary patterns. So we first initially extract the minute features, then minute features converted into a feature matrix, which is a binary matrix, and you have a stored template, you compare it, there is a matching. So in this way, it gives a matching score. So this fingerprint, it's economical. The template size is very less and it's easier to store. The entire process is very fast for the verification process. And always it consumes, as I said, very less memory space. But the problem is if there is cuts, if there is absence of extra finger or the additional fingers, then might be the recognition problem will fail. Or sometime it might happen that the system can be fooled by making a wax finger. And the last thing is, which is very important nowadays in the era of COVID, that this system actually deals with direct interaction with the, physical contact there is with the system. So these are the very demerits of the finger recognition system. Coming to the face recognition system, we basically deals with the size of the jaw, or the chin, or the shape of the localization of the eyes, eyebrows, nose, lips, etc. But nowadays, people have started working in 3D facial recognition, but 2D facial recognition is equally important now, still now. The first part we use for the detection and the alignment, and second part recognition and the coding part, which actually gives a coder ID, and that ID is used for the authentication purpose. Now, we all know about the facial matrices. In the facial matrices, there are some certain points, like the distance point from in between two eyes, or say in between two ears, or lip to say your nose. So there are some certain measures which are fixed matrix size. So based on those points, we calculate the facial matrix. Or there can be golden ratio also. Like suppose a face can be divided into 1/3, say vertically or horizontally, and vertically 1/5. So this is called the golden ratio of faces. So these are the facial matrix, which are actually the input to the system as a feature for the authentication purpose, for the matching. Now, widely used method is a eigenvalue rather eigenfaces and the PCA, where we try to analyze overall face images as a weightage combination of the number of faces. So that weightage combination is actually is a trainable one. So in this way, this eigen features, which is there can be a huge database, which can be a simplified into a small number of data set, which we actually use for the training purpose. So this is another mechanism. And another type is a skin texture, but this is very vulnerable depending upon the light condition. So lighting condition, if it is different, the skin texture might differ. So illumination or the uneven illumination, what I'm talking about, or the brightness or the contrast can be an issue. But still, skin texture, many people work on this for the analysis, finding of the faces, and go for the modeling of the faces for the generation of the coda. But most importantly, people use one particular technique, which is called local pattern finding. That is called the LBP, local binary pattern histogram. So what is that? Suppose this is a particular pixel, and for this particular pixel having the neighborhood, so 3x3 matrix. So in between, if there is a central matrix that is a 90 and all the rest not the neighborhood matrix, if I set the threshold value as a 90, So whatever the value above this center value would be converted into 1, and the rest of the value will be 0. Now, if you start scanning from one particular position, say 1, 0, 1, 0, 0, 1, 1, 0. So this is basically giving a binary string, and we convert into a binary form to decimal, and we substitute this value, this 90, with this decimal value. And this is one value which actually holds all the neighborhood information. So this way, this local pattern is converted into a binary to decimal value, which includes all the local informations. In this way, overall, this entire faces, if we find out the local binary patterns, we will get an histogram, say 141, 130, 126 in this way. We can select certain number of histogram, or we can combine all the histogram. And this histogram is basically the feature of the entire faces. And this way, this local binary pattern is very widely used for the recognition system of the faces. Now, in cases of 3D recognition, there are several algorithms. I'm just saying one is giving example of a simple way of finding the face recognition system in 3D. In 3D model, after pre-processing, we used to find 3 different cuts, 3 different points, from which point we find out the faces, which is basically the region of interest. So it's called face cut using 3 major point distance. There are several algorithms to find this particular 3 points, one nose points and the 2 eye ending points. And in this way, we find the actual face region of interest. From there can be 2 analyzation we can do. One is called a vertex property calculation, and another is the parameterization. So in this way, from these 2, we create a face map, and ultimately we get a 2D face map from 3D face map. So first one, this A, actually it's a anthropometric landscape. So the distance between various points. And second is the segmentation annotation of the areas. Third one, after parameterization. So once you parameterize, this form is this third image. In this way, if you look into this image, you can see this nose point is basically called just geodesic pole. And there are different lines. And all those lines are these concentric lines. And in this way, this is a particular point, which is the formation of the, helps to form the mesh. And that mesh, after that, we put it into a planar mesh, convert into a 2D to, 3D to C, that is a planar mesh. From that mesh, we find out the local shape descriptor. So this is the local shape descriptor of this face. Similarly, there can be a same way we can, different algorithms are there for the finding of the global pattern or the global curvature texture finding. So that is called the global descriptor. So local and the global, both descriptor we get from the mesh. From that mesh, we form one plane. From that plane, we get the corresponding texture. So that curvature texture we used to get from that. In this way, we form a 3D model, and that 3D model can be converted into a 2D map. So this map actually helps for finding the from 3D to 2D conversion, and from there onwards, we can go for facial recognition system. So this is one way of doing, but there are n number of ways. This is one particular paper from I have taken the references. So there can be many other ways, but the basic philosophy is you have to form a mesh. From that mesh, you have to form a planar mesh. From that planar mesh, you have to form either local descriptor or the global descriptor. From that descriptor, once you have both descriptor, from there you have to form a 2D map. So that is the bottom line or the main philosophy of doing this 3D study. Now, for this facial recognition system, I'm not going into more details. Rather, it's better to say what are the merits, demerits. Facial recognition system, the storage of the template in the database is easy. There are no complex statistical study in this recognition system, and there is no physical contact actually involved. But demerits, over the time, our faces changes. If there is identical twins, might not be it works. It depends upon different lighting conditions. Hello. So if the lightning condition changes, it might not work. So these are the few limitations of facial recognition system, rather demerits of the facial recognition system. Now comes to iris recognition system. In iris recognition system, the texture of the iris. Hello. Yeah. So the texture of the iris, the left eye and the right eye is different. And the texture of any two-person iris is different. So this is one important thing. The texture of the iris of a same person, left and the right eye, is different. And the texture of the iris of two particular person is also different. So that's why iris recognition system is very full, I mean, soundproof, rather better to say. So initially we acquire the iris, then from there we find out the which particular area are more focusing, that is the segmentation part. We normalize it, go for the traditional feature extraction and finding out the similarity score. But interestingly, for 10 billion people, one person is there, there can be a match of two irises. So you can think about it, how robust the system can be. Another thing is, if you use glasses or contact lens, it doesn't hamper the accuracy system. So no physical contact is needed, and it sometimes takes very fast. It's a 2 to 5 seconds it takes, because the template is very small, because iris is very small in size. So the template is small, storing is takes very less space, and it's very fast. But the problem of iris recognition system is the initial infrastructural cost. That is, a scanner is very expensive, and you always need very high quality images. Otherwise, the system will not work properly. So these are the demerits of the iris recognition system. Now comes hand geometry. Once we talk about hand geometry, there are two types of hand geometry. One is called a data points. You find some particular points. There are some different points based on the knuckle, based on the bifurcation, or based on the edges. I mean, if you study the contour, will easily able to capture those points. But it's all about the bone structure or the position of the finger you are positioning. So palm or the surface area or the length or the position of the fingers and overall bone structure. So hand geometry is vulnerable because hand geometry can change over time. So even sometimes it's used for the biometric authentication purpose, but for it's not, the system is not foolproof. Second type is called the geometric feature extraction, where particular 2 points we find out the say Manhattan distance, or might be the Euclidean distance, or we study if there is any triangle formation, what is the area of the triangle, blah blah. So this is hand geometry recognition system. Under this comes the plum identification. So palm identification, palm is a common thing where the texture and the color or the shape we can identify. But interesting thing is the knuckle extraction. Once we go for knuckle extraction, you can see in this image, there are 3 different knuckle area. And this red area is called the second knuckle area. So second minor knuckles. So these knuckles are very, I mean, completely from one person to another person is different. From one finger to other finger is different. And it is a very good biometric authentication I mean, purpose. It's very widely used. So knuckle extraction is another thing in biometry which is widely used. For hand geometry, as I said, the main merit is the skin moisture or the texture doesn't affect. But there are lots of demerits. As I said, the geometry is not unique for the adults, and for the growing children, it's different. If you use jewelry, if you use say plaster, or if you have seen any articulation, then definitely it will be a problem for hand geometry recognition system. It all depends upon the bone structure. Now coming to the retinal structure, this second image is the OCT image, and first image is the retinal images. You can see there is a dark spot. This spot is called the macula. Here is the macula. So inside this macula, actually within the I mean, from this macula to the optical cup, there is a fixed distance. So throughout your lifespan, this distance from optical cup to macula should be same. So in this way, if you extract the vessels, so in between the vessels, there are many measures which should be throughout lifespan same. But the problem is, because of some disease, there can be changes. Like there is a disease called macular degradation. So ADM, advanced macular degradation. So the macula getting degraded. Once it getting degraded, the distance from the macula to the optical cup or the disc is getting different. So that means authentication system fails. So for a person who is healthy person, whose eye is healthy, for them this vessel tree works very fine for a recognition system. Even we know that many of the cases we use eye or the retina as an authentication purpose. And secondly, there can be patch extraction, patch boundary finding. So different patches and patch classification also helps to find out one person. Like there is a disease called diabetes, where there is a patches like soft exudate, hard exudate, hemorrhage. So there can be different patches. Based on those patches, you can also identify one person. So OCT, by analyzing OCT or normal retinal images, looking at the vessel tree, looking the distance from the macula to the optical cup, or looking at the patches or the studying the patches, we can also identify a person. Now in this recognition system, it's very reliable, highly reliable, and it's very difficult to break the system. But the problem is the retinal scanner is also very expensive. For different diseases, as I said, like glaucoma or diabetes, uh, disease can be identified by the vessel tree, but the biometric authentication system might fail. And another thing is there is a major privacy issue. So privacy concern is there because health is related with the system, scanning system. So diabetes or hypertension, if there is any such kind of diseases, there can be a patient privacy issues comes into the picture. Now come to the ear geometry. In cases of ear geometry, there are lots of nodal points, and those points individually have their name. And those points use to tell, I mean, these are the very old measures are there. What will be the measures in between those points? And they are feature points, trainable points for the recognition system. Nowadays, people are working on ear biometrics. I mean, lots of works has not there reported yet now, because there are some limitations, but still ear biometrics is an emerging field. Then next come dental biometrics. In cases of dental biometrics, input image, input segmentation, then after that contour extraction, then you go for the registration process, then there will be a matching, and that matching distance will give you a matching distance or the other matching score. So based on the score, you can identify your person, might be the post-mortem or the ante-mortem images. If you're able to collect dental biometrics, another way of detecting a person. So in normal way, forget about vision computing, we used to say, this person teeth is, I can easily identify this person by his teeth. So this is the way of finding a person or identify a person. Then comes ECG biometrics. Once we talk about ECG biometrics, it's all about a person who is in rest. If the person is running, or if the person is in the treadmill, if the person is taking a class or a session in Zoom, ECG biometrics will not work. So if you are in a very rest condition, ECG biometrics works. So there are PQRST notches, which is called QRS complex. So from P to P or T to R, S to T, there are each and every points, they have their own distance. Like R to R, this measure is called the heartbeat, from one R to another R. So in this way, you can find, say, stroke, how much stroke, blood flow, and R to R measures, QRS complex, PPP, or invert T, everything you can determine. And based on that, you try to compare it. So you have to filter the ECG signal, you have to get for the segmentation. And once you put it into database, if you have a template, you compare it and you get a similarity score, and you can identify a person. But again, the person should have to be in the rest condition. If he is very normal, healthy person, then ECG biometrics works. Even apart from ECG biometrics, there are many other signal-based biometrics are there. EOG, ECG, PPG, that can be also used, but ECG is most widely used for biometric authentication purpose. Basically in multimodal cases like fingerprint and ECG, or retina or ECG in combined form. And lastly, DNA biometrics, where you need to collect the samples like swab collection, hair or the tissue collection. Then after that, you have to extract or quantify, that is called the segmentation. Then you have to go for the DNA amplification, which is basically organizing the segmentation according to the sizes. And the last one, you have to separate or detect the DNA. That can be comparison of the DNA segment with various samples. So DNA biometrics very widely used in the cases of forensic study. I have not studied a lot in DNA biometrics until now. I never explored actually. Now, this was what I was talking about. This is all about physiological modalities. Now I'm talking about behavioral modality, the second category, which is an unique behavior based on some unique behavior, the way you are working. So in gait recognition system, in gait, the way a person is working. So if you don't have a disease, the way person is working is sometimes be unique to identify a person. So suppose there is a bank robbery, we try to identify the person, the way he is working. So in this way, in gait, there are two cycles, sense phase and the swing phase, which is one of the 60-40 kind of percentage. Starting from the very initial positions, left to off, and in this way, right to off, it ends. So this is half cycle, 60%, and another cycle is almost 40% cycle from left to off to right initial contact. So in between, there are lots of different changes, and this gives you the glit cycle. So if you have a kinet sensor, from there you try to find out the cycle, estimate the cycle, you go for the feature extraction, and you normalize the thing, you go for the training model, and ultimately you can identify a person. So you need one infrastructure, which is basically a kinet sensor. So in this way, by these two cycles, we can identify a person. So gait cycle is one of the behavioral identifier, because depending upon your behavior, the working pattern will change. Now here the demerits, merits and demerits. Merit is basically it's a non-invasive, and various types of diseases like Parkinson can be detected by the pattern of a person. Demerits, there is no as such model developed based on this, and accuracy is not too highly reported in this area. But it's an alternative way of doing biometrics. Second behavioral is the signature, where there is a pressure, there is a pen which you're using, how many numbers of curvature, how many numbers of loops are there, where you are stopping points, contour. These all are different features. So pre-processing, then you go for the texture or the geometric feature extraction, find the statistical measures like crudeness, etc. Then you put it into a standard system as a feature. And if you have a standard template database, you compare it, and that will give you a signature matching score accuracy. So matching score, whatever the matching score is, based on that you can recognize. So here, how much pressure you are giving to the pen, if it is a digital signature, how much giving you pressure by your finger, or the through the pen, or the curvature which you are using over the time, that's all are basically time series data. And this time series data can be compared or studied as a time series also, the framework also. So this is one interesting way area where the time series analysis can be further explored. I don't think too many numbers of people have explored time series for signature analysis. Anyway, here the merits are, it's very difficult to imitate the behavioral patterns of others, but it's not actually, might be some people are there who can imitate the behavior or the patterns of writing. Non-invasive, no privacy issue concern. So you can share your digital signature to anyone. And another thing is, it also depends, changes over the time. The way you sign today might be not sign in the same way after 5 years. And error rate is high because it depends upon various other factors, noise level, and the way you are writing, the tilt, how much tilt it is, etc., etc. Now, next one is the dynamic keystroke dynamics. The way you are pressing the keys in your keyboard. So it's a hold time, press latency, flight time, release latency, and this is overall called the key up and down cycle. So there can be down up cycle, there can be up down cycle, there can be up to up cycle, there can be down to down cycle. So all these actually, if you record, you will get a keystroke dynamics. So that dynamics is basically used for the identification of a person. So hold time, press time, flight time, latency time, these all are 4 different time of an entire cycle of key dynamics. Now, the last one, the lip movement, the way you are talking. So the way you are talking, based on that, you can also recognize a person. It's basically used for the emotional recognition purpose. There are also some nodal points, which are draggable points. From those points, you can find out the movement of the lips, which also helps to identify a person. Oh, another one is left, that is called the mouse and eye movement. The way you are using your mouse and the eye in the screen, that screen can, if you able to record the eye and the mouse movement, that can also be combiningly used as a biometric authentication purpose. It can be used. Combined form, as I already said in voice, the cavity of the mouth is a physical one, and say your emotion is a behavioral one. So that can be combined. So if you combine that, can we give you a voice recognition system? In voice recognition system, both modalities are there. Now, once you talk about possession based, it's like token or the smart card or the QR code. So QR code is basically a generation of QR code. If there is a face, say 68 facial, say anthropometric points are there. From those points, you create a QR matrix, and that QR matrix can be used as a facial recognition system, or rather as a QR code. Or sometimes the fingerprint you can match with the card, smart card, that can also be used. So in this way, possession based is basically you have something which you can actually possess. Now, knowledge base, once we talk about knowledge base, we talk about the numbers. So knowledge base is basically the pins and the password. There can be multi-factor authentication, something you know, that is basically the knowledge base. Something, something you know, that is the password of the knowledge base. Like something you are, that is the fingerprint. So that is basically the physical or the physical based system. And something you have, like your smart card or something else, that is basically your possession based. So these are the 3 different categories. Now I'm coming to a little bit of deep learning part. I think I'm not taking too much time. It's 10:40. Okay. So in deep authentication, generally in deep learning, basically the way of learning is something different. So we actually learn in a different way. Like in Cartesian, if I try to draw a single line to discriminate this circle and the rectangle, or the triangle, it's very difficult. But if you change into polar, then if you draw the line, might be you can easily get a circle. That cycle will separate these two geometric figure. So here the learning is almost same, but the way of learning is different. The representation is different, and that is basically the notion of deep learning. Now, in our case, it's a simple case it's a binary, say, matrix, and there is a 3x3 matrix. Basically, this is called a kernel, and this kernel we will stride, and each stride there is a local binary pattern generation. So these all local patterns are features which is generated from the image itself. It's not texture feature or the shape based feature or the color feature. It's only local feature which is actually created by a moving kernel, by striding a kernel. In this way, you get different patches. These are called local patches. Now, if you have a filter which is able to, say, identify the horizontal contour, now you try to go for sum of product. That means this entire matrix and this matrix, you will take the sum of product. So this is called the convolution operation. So there are 3, 1. Here is also 3, 1. So sum of product will be 3. So in this way, if you stride, you will get different value, and all these are convoluted value. So in this way, you will create a feature map. So this is your feature map. Now, if you repeat the whole process, if you change the kernel and repeat the process, you will get another level of feature map. So this way, you can create your own feature map. So now, if you have a filter, these are the 3 which is actually getting from the sum of product of this filter and this matrix value. Now these 3, who are contributing? This matrix This 1, 2, 3 and 4, 5, 6 is not contributing. 7, 8, 9 is contributing. 10, 11, 12 is not contributing. 13, 14, 15 is contributing. 16, 17, 18 is not contributing. So 1, 2, 3, 7, 8, 9 and 13, 14, 15. They are only contributing to get 3. So this is called shared weight. The number of connection getting lesser. Thus network is converted from the dense to a shared network and the entire complexity of the system getting lesser. In this way, fewer parameters, you change the stride it, you change the filter, you will see for -1, 2, 3, 4, 6, say 8, 9, 10 is contributing, and here 13, 14, 15 is contributing. So in this way, it's called shared weight. Now, here all those patches, if you put into a single 1D array form, and if you pass through some neural network individually, you get different output. All those different output you put into a matrix form, and that matrix from there you get the max. You take the max out and you will get an output that is called the max pooling. So this is basic philosophy of deep learning, where we use the shared weight, not the, it's not a dense connection. It's not from x1 to every node will be connected. Only the node you required for the next level is only connected. So it's a shared weight connection. In between, there is some activation function. In general, it can be ReLU, it can be sigmoidal. Ultimately, there is a fully connected layer, and final layer is a, if you use a, say, sigmoidal, it might give you a probability. So the person is, you are able to recognize or not recognize. It's a real or the fake, or false or true. So in this way, it will give you a recognition system. So it's a general view of CNN. You can see here, there is a finger vein device from where you get the veins and you put it into CNN. You try to find out the features and you go for the Euclidean distance difference measures. And if there is a threshold, the threshold will identify or tell you that the authentication is failed or success. So I'm showing only one framework, but there can be n number of framework where you can use this CNN, or sometime might be apart from CNN, handpick feature also works fine. And then might be the classifier or some distance-based matrix calculation and thresholding will give you an accurate result for the recognition system. So in this way, deep learning can be used. Another way of use is the GAN. GAN is basically translation from one image to another image. Suppose if you have a summer image, you convert it into a winter image, but the system is very complex, robust, and there is a cheaper solution which is called neural tile transfer, where we transfer the style of the background or the texture of the ambience. Rather, if you have a style, you change the style into, say, starry. So starry stands for you convert the whole image into another texture. So these two techniques we can use for the authentication purpose also. How? Before going to that, let's talk about GAN. GAN, actually, there are two modules. One is called the generator, one is called the discriminator. So generator creates fake data from the noise pool. Suppose there is a latent space. From that latent space, using Gaussian and the normal distribution, if the noise are Z, the generator creates an image which is called X. So X equal to GZ. Z is basically the noise. That might be a normal noise, that can be an uniform noise, which is coming from this latent space. Now that noise actually creates one image, which is a fake image, which is called X. So generator creates a fake image, which is not actually real. And that you have a real data sample, you try to compare it, and the discriminator, the second part, is always try to discriminate, is the generated image is fake or it's a real one. So it always gives a percentage. So it always gives a rather probability that is the image is a fake image or is the image is a correct image. So there is always a tussle in between the generator and the discriminator. Discriminator always try to make full, generator always try to make full to the discriminator, and discriminator always try to protect itself from being fooled. So the data generated by the generator is a fake data, and the discriminator always try to find the data is real or it is a fake data. So this tussle continues. So generally, there is a generator G, there is a noise space Z, and if there are some parameter tuning factors. So these parameters, there are theta 1 is a parameter, and the output is basically x. X is nothing but a fake image. Now the second part, that the discriminator part, x is the input, the fake image, and there is a parameter x, say theta 2, and the output is 1 and 0. In between 1 and 0, it will tell you the probability, is it fake or is it real? So that theta 1 and theta 2, that is the theta of I, needs to be tuned. Now, in this way, the training continues, and after a certain point of time, we will see always there is a maximization and minimization effect. What is maximizing? The probability of any real data x needs to be classified as a real data. And what is the minimization? The minimization is the fake image should not be classified as real data. So fake image will not be detected as a real image. I need to minimize it. And what I need to maximize? I need to maximize the real image should detect as a real image. So it's a max min problem. So always we try to maximize dx, discriminator. And what we try to minimize? We minimize the d of zz. Whatever the generated image, that is the zz, it should be minimized. In this way, after a certain number of iteration, we will see that the generator is able to train itself in such a way that it can create more and more realistic data. Not the fake data, but more realistic data. And the discriminator is actually getting fooled. So in this way, there is a loss function generated. That loss function will tell how incorrectly it is classified as real or as fake. So that is basically a probability function, which is called logarithm. Because once you find out the penalty by means of log function, the log function probability will be very highly penalize the incorrect classifier. So that's why we use logarithmic probability. So logarithmic probability actually gives a high thrash if there is a penalty, and that penalty will be very high penalty, heavy penalty. So always if there is slight error or slight loss function in the discriminator end for the incorrect classification, that will be highly penalized. Now in this way, after several training, once time it will stop. The generator will stop generating more realistic data, and discriminator unable to distinguish this generated image is real or fake. So in this way, it will stop working. So this max min entirely can be written as a simple equation of, which is called a Nash equation of game theory, where there are two parts. One is the discriminator part, one is the generator part. One we try to maximize, one we try to minimize. In between, there will be a optimal state where the equation will get optimized and we will get the data, which is a fake data, but might be detected as a real data or realistic, more realistic data. So this entire thing, this CGAN, can be used in fingerprint reconstruction. Like if you have a generator, it creates a fingerprint from this noise pool. This is not actual fingerprint. This is generated from the noise. You create a fake image, and that fake image is compared with the ground truth, and might be the discriminator is able to detect this as a real data, which is not actually a real data. In this particular paper, you can see there is a database which is called Biocope 2013 database, where there was 500 clean fingerprint data, 500. So each and every fingerprint from there, they created 100 different samples, latent samples. So GAN generates 100 different data from individual data. And you can imagine how large the database converted. So it's a 5 lakhs database. So from 5,000, they converted into a 5 lakhs databases. So if you have lots of data, lots of variants, the system will be much more robust in nature. So in this way, you can also increase the pool or the data bank of your authentication system to make the system more robust. Now, this is another example of style transfer, as I was discussing. So in CVPR conferences in 2008, this paper comes. I need another 10 minutes, I think. Okay. So this conference, this paper comes where people use this styles transfer for removal or applying makeup. So if you have a source image, if you have a reference image, you can change your appearance. So reference and the source image, there is an appearance change. You can see every image source and the reference image, appearance changes. In this way, you change the style and the image also getting changed. So if you have a makeup, that might be the face recognition system might work. So if you use similar kind of tiles transfer, and you can create your own makeup or remove your own makeup, so that the system will be much more robust. So in this way, tiles transfer can be used in future for biometric system. This is not actually used for biometric system. This is simple for fashion designing. They come up with this paper for the application, I mean, applying and how to remove the makeups. But I think this is a good way of doing things, putting things in biometric authentication also. Now, coming to the application part, here is one example of an application. This is your fingerprint. You transform into a feature vector. Now, this feature vector, if you give a random bias, so you create noises, you take the inner product, and every inner product, if you thrash it, you threshold it, and above the certain value might be 1, or below certain value it will be 0. So the entire feature vector might be a binary decimal value, and this is noise also a decimal, might be you take the inner product. In this way, you get a binary string. This binary string can be used for two-phase authentication. This is called biohashing. This can be used for any kind of physical or behavioral modality. It's not depends upon which type of you are using. It's not, it might be finger, it might be face, but it's a biohash coding technique. So in general, a physical, any kind of modality we use for this generation of this biohash code. Now, this is one application. Second is biometric can be as a service we can use. Like if you have a edge devices, if you lots of edge devices that can be connected to the fog, and finally it can be connected to the cloud. So in this way, biometric authentication system in layer to layer you can use. This is called the cloud-based biometrics, which is biometrics as a service you can also use. Challenges, biometrics are not private. So this is one issue. Biometric template needs to be protected because it should not be tampered or it should not be hacked. If it is hacked, might be many systems can break, security system or health system if it is depends upon the biometrics. So you need to properly preserve it, protect it. Another thing is cryptological primitives. This is one major concern I'm not discussing. And the last one, there should be some error correction based method which you need to correct properly. Otherwise, the authentication system most of the cases fails. And last but not the least, which I want to mention, lots of people are coming with multimodal models like finger with faces with git. That can be done, easily done. You can increase the modality, but always you have to remember the complexity of the overall system for the recognition process. A person should not wait for a long time in a queue to identify himself or herself. So that's why position-based is most people use this for authentication purpose, apart from other knowledge-based and the physical systems. And last slide, biometric authentication is a sub-part of forensic science system. And forensic science system is a sub-part of intelligence system, which includes criminal justice, which includes law enforcement, which includes military system, which includes security. So these are all interrelated, but basically biometric system is a second subsystem of the forensic biometric is basically second subsystem of the intelligence system. So this is one sub part of the whole system. So criminal needs to be identified. If you arrest him, in between there is one subsystem, second level subsystem, which is called a secondary biometric system or forensic biometrics. Thank you very much. I am done with my presentation.
Yes, thank you, sir.
Thank you.
Good morning, sir. This is Dr. Sakshi Paithane. Thank you for this informative session, sir.
Thank you very much.
So I have a few questions. Can I proceed with the questions, sir?
Please.
Yeah. Thank you, sir. Which biometric-based authentication is widely used commercially, or the R&D is going on that?
Commercial is different, R&D is different. Commercially, if you ask me, so I will say fingerprint is still commercially very viable, because as I mentioned, if you go through the merits of the system, of the fingerprint system, there are major merits, and the merits are here are the merits. So it's a very economical, first thing. Second thing is initial infrastructure is not costly. Third thing is the template site which you needs to match, that is very small in size in compared to other like faces or ear. So that's why it takes lot of less memory. So memory point of view, speed up point of view, template preservation point of view, uh, this is one most economical and cheaper solution. So this is one widely used. But apart from this, face recognition also very much popular. But nowadays they are having lots of data privacy issues are coming, and many of the countries they have their own rules to not to go with face recognition system, which comes out few months back also in newspapers. And if you talk about I mean your R&D purpose, R&D purpose nowadays biomedical signal processing is widely people are using. Uh, Even in deep models also, like biosignals. I'm not talking about the physical modality like finger or faces. Lots of work has been done in this area, but biosignal it's yet to explore. So this is one area where people are nowadays mostly working.
Yes, sir. Thank you very much, sir. In line with this, the next question is from the participant that how will you, sorry, sir, is there any specific reason that thumb is generally used for authentication other than the remaining
Which
four
one?
fingers?
Oh,
Thumb is generally used.
No, it is very common that in the thumb, the pattern you will get, it will be a full pattern. You will get either arc or hole, any kind of pattern. You will, the surface space is larger rather than these other faces, the other fingers. The scanning surface space is larger, the area of scanning.
Yes. Okay, so that's the reason.
Hmm.
Thank you, sir. The next question is, how will you rate biometric authentication against password authentication?
Password-based authentication is always vulnerable, because password-based authentication, even it's a knowledge-based, but password-based, there can be always, I mean, if crypto system is also can be breakable easily nowadays. So it's not depends, I mean, very much I mean, trustworthy, I think. So captcha, second level captcha for the password might be a solution, but still possession based or sometimes biometric is more foolproof rather than password.
Sir, but biometric inputs that are means the chances of changing the patterns and all that is there. So which cannot be happen in case of digital password authentication. So that's a question from the participant.
That's why this is kind of OTP, which is basically a biohash code. So biohash code generation is a one solution where you generate the biohash, but depending upon your behavioral or physical patterns. So it's an integration in between the, you can say it's a bridge between the generated password and the, I mean, password and the physical or behavioral property. Because you are actually trying to club together for biohash. So another thing is this biohash actually not very much, I mean, explode still now. We come up with a paper in 2014, I think long back, 13, 14 that time, this biohash. But still lots of work can be done in biohashing. It's a one-time generation OTP from the behavioral and the your physical patterns of the person. So
yes,
but this password, 7-word password can be easily break. I mean, any of my BTech student can break. Many of my BTech student can break.
Yes, sir. Yes, sir. The next question is one of the participants want to know about the database of biometric.
Database of biometrics. For all different modalities, there are different standard databases. Like I only discuss one database, which is the Bio 13 database for the finger. But apart from these, for all modalities, for finger, for face, different database. But there are few modalities where you will not get the real standard data set like Git. So for that, you have to come up with the proper infrastructure. But if you think, then you can, if you have any query related to database, if I will share with you. You can drop me a mail in this mail ID. So these are two of my official mail ID. Anyone can mail. I will try to definitely reply.
Yes, sir. Thank you, sir.
Because I'm not mostly from biometrics, I'm from biomedical. But 2-3 months back, I have a talk in this institute on biomedical. So I thought I should change my topic to biometrics rather than biomedical. Okay. So any more question from any participant? I think we have 2-3 minutes more time. So please.
Yes, sir. Actually, for database, one of the participants is asking for fake biometric database. Any
Fake
source
biometric?
for this?
Oh, you generate your fake biometric database by yourself by using GAN. Because see, the fake biometric data which you are generating, that is basically you are generating from the real data itself. So you need a standard data pool, like say 500 data. From there, you create your own data, either by tiles transfer or by CGAN, and you create your own data set. You make it available for everyone. We will also get benefited. We will use that and we will cite that one.
Yes, sir. Thank you, sir. With
so
this,
I don't think there is standard database. I don't think there is. Okay.
Thank you, sir. With this, we are at the end of question answer session.
Thank you, ma'am.
I, Dr. Sakshi Paithane, on behalf of Rajarshi Shahu College of Engineering, Department of Electronics and Telecommunication, takes this privilege to propose vote of thanks to Dr. Nilanjan Dey for accepting the invitation. Thank you very much, sir, for this
Thank you, ma'am.
informative.
Thank you.
And definitely there are important takeaways from the session. Thank you, sir.
Thank you very much. So if anyone having any query, you can write offline, no problem. I will try to reply. Thank you very much. Good day.
Thank you, Nilanjan sir, for sparing your valuable time with us, sir.
Thank you. Thank you, ma'am. Thank you.
Yes, Shraddha madam, is there any announcement related to next session?
Yes, ma'am. The next session will start at 11:45. So we will meet back at 11:45.